Hello viewers, you are welcome back to Tindanius Maths and Science tutorials. We are going to consider more questions under differentiation from first principle. We've been solving some, so I want us to appreciate the significance of differentiation from first principle. We have the question on the board. Differentiate from the first principle, y equals x squared plus 2x plus 1. Okay, we know that from differentiation from first principle, the formula is this. We know that we have f, we have it this way, equals lim. As my h approaches 0, then we have this whole expression, right? So now, this is the question I'm being given. So I will have to look for my expression in terms of f of x and in terms of f into bracket x plus h. So here, this function y is the same as f of x, which is equal to what? X squared plus 2x plus 1. Then I'll have my f in bracket x plus h. Now wherever I see x, I'll write x, then I'll increase it by some h. So me increasing by h, I will say delta h, right? So that's delta x. So delta x is the same as h, okay? So here, I can see x here, so I'll write my x. Then I'll add what? Either my delta h or let's say my delta x or h. Then, this whole expression is for the x. Then I will square it in that order. Then plus, I have 2 here, 2. Then I have x here again. So what do? So I'll write my x, then I'll increase it by what? By h. Remember, wherever you see x, you write x plus h. Then plus what? Plus my 1 over here. By expansion, I'll get, when I expand this, I'll get x squared plus my 2xh plus what? My h squared. Then plus, when I expand this, I'll get 2x plus 2h. Then plus what? My 1. That will give me my f into bracket x plus my h. So that means, based on this formula, I have this, right? And I have this. So now I'll now come and look for this expression, minus f of h, all over what? H. So that's my next step over here. So I'll write f into bracket x plus my h minus my f of x all over my h. We are trying to simplify it so that when we are done, we just substitute it directly to onto the formula, then we solve for our what have you. So what is my f into bracket x plus h? It's here. So I have x squared plus 2xh plus my h squared plus my 2x plus my 2h plus 1 minus, where is my f of x? My f of x is here. My f of x, in terms of x, I have this whole expression. Because it is an expression, I will enclose it using my parentheses. So I have my x squared plus my 2x plus my 1. Note, it's an expression, so it has to be in parentheses. All over what? All over my h. So, let me simplify it further. I have x squared plus my 2xh plus my h squared plus my 2x plus 2h plus 1. Then I'll expand using the negatives. So minus x squared minus 2x minus 1. Negative will affect everything here. So clearly negative 1 will take off positive 1. The negative x squared will cancel positive x squared. So I'll have, this is over h. So I will have what? 2xh plus my h squared plus 2x plus 2h. Then, clearly, positive 2x will cancel negative 2x over here. So I'll just write this way. I have 2xh plus h squared. I have plus 2h. Everything has been cancelled here. All over what? My h. By factorization, what is common here is h. So I'll factor h out. H will cancel h. I'll be left with what? 2x plus h will cancel one of the h here. I'll have h. Then plus h will cancel h. Then I'll have 2 all over my denominator h. Clearly, h will cancel h. So therefore, my f into bracket x plus h minus my f of x all on h is giving me a simplified answer of what? 2x plus h plus 2. Right? So now, when we take the limit, so we have that dy over the x is equal to f prime of x, which is the same as lim as h approaches 0 of this whole expression minus f of x all on h is the same as, what is f of x plus h minus f of x all on h? The whole of this I've already solved, and I had what? I had this, because you can see clearly. So that's the importance of solving for this also. So I'll have 2x plus what? Plus h plus 2, right? That's it. But we are saying as x approaches 0, so wherever we see, as h approaches 0, so wherever we see h, we'll put 0 there. So this becomes 2x plus 0 plus 2. So that is our dy on the x. So therefore, finally, our dy on the x will be 2x plus what? Plus 2. As simple as that. So this is using differentiation from first principle. Let's employ the other way around without the use of the formula. How can we go about this? Please take note. The other formula we use is the same. The other alternative we use the same as differentiation from first principle, where we use delta x and delta y. So this is the solution, as simple as that. If this is your first time, you can visit our previous lessons under differentiation from first principle, and trust me, you will understand everything over there. So let's employ the other way, the other formula. We said that whatever you do to the left hand side, do the same to the right hand side. When you see y, just write y, then you add change in y. When you come to the next time, when you see x, write x and add change in x. That's all. So let's do the same thing here. Here on my left hand side, I can see y, right? So it's y, then plus I'll add what? Change in y. That's how this method it goes. Now I have x here. So I write my x. Then what do I do? Because there's x here, I'll write what? Plus change in x. What has happened to the x, or what's happened to this x? It has been squared. So I'll also what? Squared this. I'm done with that. Then plus, I have 2. Wherever you see the x, you just write the x. Wherever you see x, just add plus change in what? In x. That's all. Then plus 1. Then I have, you can expand. So you have y plus change in y equals, when I expand this, I'll get s squared plus 2x. Then I have change in x plus change in x all squared. Then plus, I have 2x plus 2 change in x. Then I have plus what? Plus 1. So always for this method, change in y will stand alone over here. So that means this will cross. So to be change in y equals, we have what? X squared plus 2x change in x plus change in x squared plus 2x plus 2 change in x plus 1, then minus, because I'll transpose this minus my y. What is y in terms of x? I know that in terms of x, my y becomes what? From the question, you say y is equal to the whole of this, right? So I'll write x squared plus 2x plus 1. Then I'll just substitute that into what? Into this y over there. So finally I have change in y equals x squared plus 2x change in x plus change in x squared plus 2x plus 2 change in x plus 1 minus, now I'll put it in parentheses because y is an expression, you get it. So into bracket, the whole of y in terms of x is giving me x squared plus 2x plus 1. Then we will simplify. Change in y equals x squared plus 2x change in x plus change in x squared plus 2x plus 2 change in x plus 1 minus, then just expand, x squared minus 2x minus 1. So clearly negative 1 will cancel negative 1, negative 2x will cancel positive 2x, and what else? Then negative x squared will cancel positive x squared. So we have change in y equals 2x delta x plus change in x squared plus 2 delta x. Everything here has been cancelled. Now when we reach here, remember gradient is what? We have the change in y over what? Change in x. That's for gradient, which is the same as what? Dy over dx. So that means change in x will have to divide. So when you get to this place, you say dividing through by change in x. When I divide through by change in x, I'll have change in y over change in x equals 2x change in x plus change in x squared plus 2 change in x all over change in x. And remember we said when you have something like a plus b plus c all over, let's say w, this is the same as a over w plus b over w plus c over what? W, because they have a common denominator. So the same is applicable over here. So I have dy over my dx, or change in y over change in x is 2x change in x over the denominator, which is what? Change in x, plus change in x squared over my denominator again, change in x, then plus finally we have 2 change in x over the denominator, change in x. So clearly this will take off this, this also cancel this. So I have change in y over change in x equals, this will give me 2x plus this will cancel one of this change in x. So I'll get change in x, then plus what? 2. Then you know that lim as change, so lim of the function as change in x approaches what? 0. So this finally becomes, wherever I see change in x, it will go to what? It will go to 0. So I have 2x plus my change in x here is what? 0, then plus what? 2. So therefore my change in x, which is the same as my dy over my dx, is equal to what? 2x plus 2. As simple as that. See how it's very simple. So this is differentiation from first principle. Let's solve this example. So I will give you a question to solve, then when we meet again, we'll take it from there. The question is, from the first principle, find the derivative of this function, y equals x cubed plus x. I'm waiting for the answer in the comment section. See you next time. Subscribe, like, and share. Bye.